Hello everyone. So here we are back with another relatively short video. This is going to be a solution for another simple force question. This one has a bit more complexity than question number 15 from study guide week number 2, but they're all relatively similar in the idea that they're using Newton's second law of force equals mass times acceleration. So here's the question. A 500-gram sled is being pushed on a ramp. It accelerates from 10 meters per second to 50 meters per second in 0.5 seconds. What force was applied to the sled to give it such an acceleration? So here's our picture. We once again have a sled, and this sled is being pushed. We're going to put the arrow this way with a particular force that we don't know of yet, and it's being pushed on the ramp going in this general direction. You'll notice I don't have an angle to this ramp. If we had an angle, we'd have to change our force equation and put in a theta factor, and we're not going to do that here. This is just going to be a flat ramp. So again, we have this sleigh. It's being pushed on this ramp with a particular force. We know that the sleigh is 500 grams. It's not particularly heavy, relatively lightweight. So we're pushing this thing. It accelerates from an initial velocity, VI, of 10 meters per second, and it eventually gets to a final velocity, VF, of 50 meters per second, and it did that in a time frame of 0.5 seconds. So this is our problem. This is how it's laid out. We've written down everything that we're given. Now, once again, recall Newton's second law, force equals mass times acceleration. We already know what our mass is. Our mass is 500 grams. And remember, when we're dealing with force equals mass times acceleration, force is in units of newtons, and newtons is units of kilograms times meters per second squared. So even though we've got a mass already of 500 grams, we actually want to convert that mass into kilograms so that we have proper units. So 500 grams, in fact, let me do a full unit conversion for you guys. We'll do our train track again. And recall that 1,000 grams is going to equal 1 kilogram. So now when we do this, grams cancel, we're left with kilograms. So mass is actually 0.500 kilograms. So that's what our mass is. Now, here's the deal. In order to calculate force, we need to know what the acceleration is. We've got mass, but we don't have acceleration. But what we do have are two velocities. We've got our initial velocity and we have our final velocity. So acceleration, as you guys recall, is simply velocity over time. But in this case, we have two velocities. We have our final velocity minus our initial velocity divided by time. And this is going to give us our acceleration. So here, this is a change in velocity over time. That's what acceleration is. So let's just plug this in. We know that our final velocity is 50 meters per second. We know our initial velocity was 10 meters per second. And we knew it took a half a second to get to that change in velocity. So now we just have acceleration equals 50 minus 10, or 40 meters per second, over a half a second to do so. And that is going to give us an acceleration of a lofty 80 meters per second squared. So now we have acceleration, we have our mass, so we just go back to Newton's second law, force equals mass times acceleration, which equals 0.5 kilograms times 80 meters per second squared, which equals 40 newtons. And remember, 1 newton equals 1 kilogram times meters per second squared. So we're just saying that this 40 newtons is actually 40 kilograms times meters per second squared. We've just changed the units to newtons. So that's the answer to this particular question. Pretty straightforward. Once again, another relatively simple force equation, force question using Newton's second law. All right, that's it. More videos and more explanations to come. Thank you. Talk to you later. Bye-bye.